Hello everyone. We have Srijan with us today. Srijan will be speaking about the emerging architectures in AI systems, control loops, and abstractions shaping agentic systems, and where the real technical moat is beginning to form. Srijan, if you could introduce yourself first, and then we can take it ahead.
Hi, yeah, sure. So, like Saurabh mentioned, my name is Srijan Shukla. I work as an SRE at Steel. But after working hours, I spend almost all my time in spending all the tokens for all the LLM subscriptions that I have. So, yeah, this talk is about a lot of patterns that I've noticed in the coding agents and also, various little ways to optimize your workflow. So actually, one of the things that I've noticed is that the more you dig down deeper on how these coding agents work, the insights and the patterns you notice there, they can also translate very well to any other parts of your workflow in day-to-day. And also when you want to be building AI agents that you want to run in production, it's mostly similar designs that you see all across. And the other thing is, this is the new addition that I think is for like to the broader topic of system design in tech. So long ago we used to ask in system design interviews, you know, what happens when you type google.com in your search bar and press enter. And now if you translate that, you should know what happens when you type a prompt into your coding agent and what is happening under the hood each steps. And so basically that. And we'll just start off with my presentation. So this is the state of things right now in day-to-day life. It's almost impossible to keep up with the new tools that come up. There's new model releases, there's new harnesses, there's new skills, new plugins, new toolkits, new workflows. And it's very fast moving. And again, that's what I'm trying to, summarize into this talk. And I think that there are three layers at which you can control your workflow. And that is the model, the harness, and the context. And people talk about context collision a lot and, being surgical about what the context is. And very early on, we used to only talk about prompt design, but you should be able to know what is happening with every API call that goes to the model provider and what it constitutes of. And then there's the harness also that you can have some control over. But it's tough to switch on harnesses in the middle of your workflow. But still, there are even tools to do that as well. And some of the harnesses will let you switch the model and the thinking tokens that you can spend per turn. You can change it from turn to turn. So depending on the workflow, what your experience is for different models with different thinking budgets, you can have that control as well in your workflow.
So which are your go-to models for coding as well as for research?
For deep research, I prefer Gemini because Google has the moat for search, I believe, and Perplexity is also pretty good. But for general planning, big picture, you can use both the frontier models. I use both the frontier models. So as of today, Opus 4.7 and GPT 5.4. So you let them both battle out, and they always, they are very good at finding faults with each other's plan. And then you can switch to a medium thinking budget Sonnet or a medium thinking 5.4 to execute the plan, and the same cycle then continues. Like
so when you create a plan, you give the same plan to both Opus 4.7 and GPT 5.4, and when you say you see them, you battle them out for the best outcome. Is it a back and forth between them, or you look at individual plans and then you take a call that this is the better one?
So it's usually like my main long prompt to start a plan. I will give it to both models, And in plan mode, they will both ask questions and come to a synthesis of produce the final plan artifact. And then I will usually end up using one of these models to synthesize the plans from both of them and like fill any holes that one of the models missed. And then, yeah, that
so there is the human in the loop comes in once both the models have produced their plans, and then you decide, okay, this is better, I'll go with this guy.
Yeah.
And does it lean towards one model, or is it like, it's sometimes 4.7 is better, sometimes 5.4 GPT 5.4 is better?
Yeah, so for very hardcore engineering use cases, from my experience and from what I've been following on Twitter as well, is that 5.4 is a better engineer, and 4.7, 4.6 Opus that I've had more experience with is a better general case. If you have more bias to build and not the engineering use cases, then the Claude models are better.
Okay, and this is still in the plan phase. When it comes to execution, you'll look at another model just so that you can. Is it from an economical sense to save tokens, or do you feel that the frontier models are overkill once you have a very good plan in place?
I think the frontier models are a bit overkill when you have the final plan in place, because I'm also making an assumption that the final plan is very detailed. So what I prefer is keep it as a checklist. So, and the executor model, whichever it is, preferably a fast model, but it treats the plan artifact as a checklist, and there's like very detailed steps of execution. So there's no ambiguity on what is happening once the executor finishes. Yeah,
one of the things that I do during my plan creation is I create a preliminary plan, and then I tell the model to extend the plan with checklist and phases, right? Yeah. So the phased approach really helps, so that I can do phase 1 through Opus, and maybe I if I don't see good good feedback there, then I can switch it at the second phase rather than giving a big bang plan with a very long checklist, right? So do you see that advantage when you are able to break down the plan also into committable artifact areas, right?
So either the checklists itself can be a checkpoint for the agent to track, but phases is another way to you can group the tasks. And one more good way to separate out the phases is what you can test out. Like in many cases, you can hand off the testing also to the model, good at writing unit and integration tests. But for some of these cases, I think there's still human in the loop required as the final quality check of the code that you're producing. So for those, that it's a good approach to have those specific checkpoints and test one flow that is completed by the model.
Understood. Cool.
Yeah.
Got it. Yeah. Let's move on to the next part that you know.
Cool. Yeah. So here I want to highlight one thing that a lot of times people assume that it's the model quality when they have a bad result, and they're very quick to dismiss a whole class of models like, oh, I'm not going to use Codex ever. It gave me a very bad result. But it is actually, in my opinion, mostly a mix of the context and the harness. And the harnesses, the raw harnesses from the Codex and Claude Code are continuously improving. All of them are the open source ones. And the context should be, I think, as an engineer, you should be cognizant of what's going in your context every time.
So when it comes to harnesses, do you rely more on the stock harnesses? Like in my experience, if I'm using Claude, I just use Claude and this checklist based approach. I've seen a lot of people use the frameworks like OpenSpec, GSD that get shit done, and all of that. Do you think those really make a difference when it comes to not too heavy tasks? Like if you are doing run-of-the-mill stuff like web application, 3-tier stuff, REST API, CRUD related stuff, do you need that extra layer of harness above the stock part that Claude or OpenCode would provide?
I think it completely depends on the level of control you'd like to have, and most engineers would prefer absolute control because they have the full mental picture of what they want to achieve. But if you are more on the vibe coding side and I mean, you don't want to be micromanaging engineering workflows, then these prompt templates come in very handy for a non-technical person to like completely go through a workflow which is pre-templated out.
Got it. So
Yeah.
which is beyond the stock harness? Are there any harnesses that you would recommend?
So it's coming on the further slides, but
Sure. Let's come to that. We'll go through that.
State of the art, right? So I mean, some of my friends, I keep cracking this joke. What is SOTA now? What is state of the art? So for all the layers, there's different state of the art, and for Pi agent, which we are going to talk about, is state of the art, I think, for engineers, coding agents. So the next thing I want to go back a little to the history of how we are, how we ended up here. So earlier last year, 2025, the Claude Code stock is what everyone was using without any modifications, and that itself was a huge unlock for everyone, a very different way of writing software, and the way they interact with their code changed completely. But at some point then people started to zoom out and started engineering things around the coding agent. So Ralph Wiggum loop, this came up like second half of last year, and this was a huge unlock, which was basically these coding plans would have these 5-hour session token limit. So you could have your agents running at all night and wake up 2 PRs to review. And what it did was very simple. You prompt the coding agent for specific stop conditions, and you keep asking the agent to loop over. Like there's a wrapper which loops over the prompt, and the same checklist thing that we discussed, right? So I say that until the checklist is complete, keep working on the next items. And when the checklist is complete, emit this string of text. So that would be my exit condition from the loop. And this was very helpful because earlier models had a limited output context window. So that problem's reduced now. Nowadays, models are RL'd to perform very long horizon tasks. And that is one of the emerging abilities with the RL that is done for the frontier models. But earlier, this was one of the engineering examples of zooming out of the coding agent and engineering around it to get desired results. And that was the beginning.
When you say that now that the output context window is increased, how does that affect the Ralph Wiggum rule? Like if I have a very exhaustive plan and I know that this is going to take time, I put this. Like, what is the difference between me just handing over a plan to an agent and it being very exhaustive versus using Ralph Wiggum? Like, if my plan is exhaustive, I know it's going to take like 3-4 hours. I'll just do that, like switch it on and go to sleep. Why should I use Ralph Wiggum?
I have noticed in personal experience that if with very exhaustive plans, even the frontier models will stop halfway, and they'll be like, hey, I'm done with this much. Do you want to continue? But also, so interesting that you mentioned that, because I think these harnesses are doing some smart logic on how these input and output tokens work. So someone found out that in Claude Code's case, when Claude Code is suggesting something, an action which the user did not, and in a later turn, Claude Code suggests that, oh, you said this, whereas it was actually the Claude Code that suggested the action, but it hallucinated in that bit. So they are doing something around, the output from the model itself becomes the input in the next turn. There's some engineering magic happening in the harness around that. So that's another way these models work very long. But that's the.
So you are saying that because the model will, like on an exhaustive checklist, it might stop in between and ask for suggestions. It is better to have the loop running so that this condition can be prevented.
You can be very sure if you prompt the model to emit a certain like stop condition text that it is done with the plan exhaustively.
Got it. Because when I first read about Parkinson's law, It sort of, when I first read about Ralph Wiggum, it sort of reminded me about Parkinson's law, that now suddenly people have work that can span nights. Earlier, it didn't happen, right? So the work expands to fill the time that is available.
This
So
was not even a concern for any engineer to have the computer running all night doing something. Yes.
Right.
True.
Good. All right. Moving on.
Yeah. So this was the beginning, and the current state is tool chains like this, which are the idea of what you see on my screen now is basically handing over your entire Jira board to the AI agents, and they orchestrate among themselves, and each ticket gets an agent of its own to finish. And there are many examples of such projects like Paperclip, Mission Control, Symphony. So yeah, what you see on my screen is Mission Control. Different AI agents having different roles, picking up different tasks. And Paperclip is an example where you have a full org design like you design the org, and each block in the org design, each employee is an AI agent of its own, picking up tasks from the board and so on. So this results, you can imagine the kind of like unprecedented levels of AI slop you can produce with these tools. And if we are not careful about what the final output artifacts are, then this can devolve into something that we do not want. So
also, do these tools give you a way to know which parts can be parallelized, which parts can be serial? Like, for example, to use an SRE analogy, right? If I'm doing a Terraform plan, then there are parts of the infrastructure that can be created independently. There are parts that are dependent on each other, right?
Exactly.
Not create a security group and associate it with an EC2 instance till I create the EC2 instance and all of that, right?
Yeah.
In these kind of tools, this mission control, Symphony type tools, when you create a Jira board like this or whatever equivalent of the agent like this, can you create a dependency so that when two agents throw themselves at two different tasks, they decide, oh, this is supposed to be done before this, so I will hold off till it is done? Does it Ralph Wiggum itself into waiting for another agent to be done?
Yeah, so I have noticed that pattern in Paperclip, that this dependency is not like being done runtime when an agent picks up a task, but they use the dependency model, which is similar to like Jira. So Paperclip has a like Kanban board of its own, and each ticket will have other dependency tickets that this ticket is blocked on the other one. So the other agent finishes on only after that.
It is up to the human to do that dependency mapping upfront.
The Paperclip model is you start with a CEO agent. So the CEO agent ideally is supposed to take care of those bits also. But I mean, you can prompt it to have the human in the loop in those workflows also.
I hope agents do not abuse their Kanban boards the way humans do. So, because if it is anything like that, we are already producing a lot of slop on Kanban boards.
Yeah.
If that slop translates into tasks for agents, then that is like meta slop for future slop that's gonna come.
Yeah, and that's what I want to highlight here, right? That's what I want to highlight. That
have you used any of these?
I have used Paperclip for a few days, and I was trying to build something very similar to Symphony, and a very opinionated version, and then Symphony launched.
In your experience with Paperclip, did you feel that doing, handing over control to this organization of agents was better, or do you feel that the earlier approach of, doing the exhaustive plan, letting two agents battle it out, and then going with the execution was a better approach purely from an outcome perspective?
For me itself, I mean, some people work the exact same way for every project, but for me, it is both sides of the spectrum, depending on how important the project is to me. If I am doing something on my workplace, for my workplace stuff, then I am very pedantic and detail oriented about like what is the agent doing. Like I'll stop the agent midway if I even see a little bit of diversion from what I want. But for many of the side projects where I just had an idea and I'm like, would be fun if I could do it, but I don't care much about the details, then I'm open to, have dangerously skip permissions with Claude and let it run with it.
Got it. So you're still in that exploration mindset when it comes to doing your pet projects.
Yes.
But you follow the more structured approach and known, well-tested things when it comes to your work-related stuff, while knowing that tomorrow when a Paperclip or a Symphony rises to the occasion and makes itself that better tested and ready, at least you will know the limitations that go in through your pet projects. Interesting. So
exactly. When I'm not thinking like an engineer, I'm like, I want this outcome. I don't care what code is being written. Then I do the other way. But even when you say on what you mentioned, let's say something like Paperclip comes up for an SRE workflow later on. Even then, there would be the human in the loop. That aspect, I think, is not going away still. So would be good to
at some level, all of these tools are also, even though one might sort of say that, you don't need so many agents in parallel and all of that, just the ability of these tools or these frameworks to exist will sort of open up the possibility of whenever a problem shows itself that fits in this mold, at least you will have something worth trying out through these tools, right?
Exactly. Yeah. I mean, I think about this, that a lot of an engineer's job is also to, when we are designing a solution, it's good to know XYZ exists, and then we can match the following to what is good for this use case. So that's that's how I approach, trying to keep up with the AI world. So
right. Makes sense.
Right. Okay. So we already discussed this. That was the next thing I was going to mention, that there's a huge divide of what we discussed. There's a token billionaire mindset of just let the agents run with everything, and there is the Pi agent, the founder of Pi agent. The Pi agent is minimal by design because his workflow depends on giving it very specific tasks and very small in scope, having maximum control over the workflow.
Right. So there was some AI engineer conference, and someone had coined this term,
Europe,
ZL continuum.
Yes.
Right? Yes. So ZL continuum is the Z stands for I think Mario. Mario's last name.
Mario Zechner. Yes.
Yeah, and L is for someone else.
OpenAI, one of the leads there.
Yeah. Mario is more like slow the F down and read your code, and the other side is this token billionaire angle, right?
Exactly. So, I think that's what the thing is. You choose where you are on the spectrum based on the thing that you're working on. And it's good to be able to move across the spectrum.
Right.
Yeah.
I mean, you may choose sides on the spectrum, but at least have knowledge that this is what exists on the other side of the spectrum.
Exactly. Because some of the patterns that you come across with these kind of projects like Paperclip, you will not notice them when you are doing very microscope tasks with Claude Code or Pi. So it's just about knowing this exists, so I can match the following in future when I need to design something with AI agents.
Right. It is sort of like, a lot of people, when they build AI applications nowadays, they may just directly use OpenAI's APIs because they are very clean and structured. But when they had started initially, LangChain and all were at the top. Right?
Yeah.
So if you inherit LangChain code, you may not like it, but it is something that you have to deal with, and it is worth knowing. So similarly, with the ZL continuum, also you might be on the L side or on the Z side. But what if you inherit work which is on some part of the continuum, right? So you have to make do with it. So it is good to at least explore these things, right?
Yeah, exactly.
And nowadays, if you explore and put out an opinion, you become, there is a lot of polarization of, stands, especially on social media platforms and all, right? So that needs to be calibrated from a reader's perspective, listener's perspective, to see whether that guy is, evangelizing you or showing that I played with it and this is my experience. Right?
Yeah, that should be the ideal posture when talking of things, because more knowledge you have across the spectrum, the better it is for you, right?
Nice.
Should be able to. Yep, that's it. So okay, moving on. So yeah, these are the patterns that I have noticed across when with all the effort I try to keep up with the AI world. So one of the first things is that the models are increasingly RL'd on doing more tool calls and working out of the terminal. So again, talking of the pi agent, it's the most simplest harness, right? The loop is incredibly simple by design, that it can run any bash commands. So the models, also the newer versions of models, they've done a lot of these post training on trying to be more agentic in how they respond. So they do more tool calls, they'll run more bash commands, and rather than just talking
interestingly, I just read like 1 or 2 days ago that Opus 4.7 now defaults to using the bash tool for doing grep and reads rather than using its internal tools, because that is apparently better or faster or whatever the decision is. So it's like going back to the primitives again.
Yes. Even I mean, in Claude Code, another example would be the LSP. They added support for LSP. I was marked experimental, and what they found in their internal evals was that just the normal tools were much better than using more, giving harness more power. Sometimes, good to keep things simple. So that is one of the design decisions that you should take into account whenever you're working with these agents in any context.
Use the tools for your tools.
Yeah, exactly, well put. So they just need a little. If you add a skill.md, after that your coding agent just needs a very little nudge for it to use the tools that you added in the context. So the next thing is security. So for security, we've learned that you will never get your way out of just prompting your model to act in a safe manner and not do risky stuff, not have destructive actions. We've seen cases of models doing a drop table in production databases. So that's a bad idea to prompt your way into security. You have to be defensive, and it is best enforced externally at the harness level. Just don't allow them.
I remember in the meetup there was a talk on using using LLM at scale to build some debug agents and all. And one of the cool things that the author had done was that instead of allowing the model to write to the file system, they made the file system in which the model runs read only, right? So that is like the ultimate level of prevention or least privilege that you can do. But on that note, have you ever run your models in a sandbox environment? Because like mostly what I do is that even if I take pi and all, I put in a permissions extension on it, and so that I can gate it a bit. Not a dangerously skip permissions fan, but I've never run my model inside a container just so that I can prevent its blast radius.
I have not done that too. And Codex comes with its own sandbox, and it explicitly tells you, I'm trying to do something, and inside the sandbox I cannot edit your .git fetch head. Can you allow me this command? But I've not run it in sandbox. But one nuance to add here is that the models differ in their capability of instruction following. So the frontier models, and this is one of the things that comes up in the model cards for these new, like every new model release, is how good they are at instruction following. So whenever I do use not the top models, I revert back to a harness which has the gated permission controls. But I do have enough confidence on the frontier models to instruction follow that I can simply say that you can use this command and do only read-only operations, and I've rarely seen it digress.
Understood.
So
So you're saying that when you are using models that are not state of the art, or which are maybe relatively old but well tested,
yes,
you would rely on a harness to give you that extra layer of security. But the
yeah,
new models, given that they will be a little more obedient, so as to when it comes to security, there you
yes,
can relax down on the harness part of it. Interesting.
yeah, exactly. That's my personal workflow, but I wouldn't advise it. I mean, depends on the risk you'd like. So
Yeah,
ideally,
because
you want
harness
security.
becomes a language, right? It becomes
Exactly.
this tone in which you talk to a model. Adding and removing it is hard. It's like a plugin for your editor that you create once, and then you will never remove it, right?
True. So by default, you should ideally, enforce the permission gate at the harness level. And that's the pattern we've seen also with all the projects that people do enforce security outside the model itself. No one tries to prompt it to do, to prevent these bad scenarios. The next thing is, the skill.md, MCPs, and hooks. A lot of these augmentations to the existing out of the box behavior of the LLMs. So skill.md is just a bunch of instructions, probably very detailed, but it has progressive disclosure. So there's like an index in the beginning, and you can have a skill.md package with a lot of subfolders you can have like 20 different markdown files for detailed instructions depending on what the model wants to. And that is turning out to be the state of the art way currently to steer your model and give them abilities to interact with different services or follow a specific workflow.
Which
And
is your favorite skill.md?
my skill.md favorite is the caveman, which results in very pure models talking
Yeah.
like Kevin from the office.
Yes, you had to bring in that internal joke. For those who have not watched The Office, please do so that you can get context of what Srijan says.
Yes.
When less token do more work, why use more
Why
token?
use more? Why waste token?
Why waste token?
Correct. I'm digressing a bit, but with Opus 4.6 and 4.7 also, that is a very interesting thing that people have noticed. There's a huge crowd complaining about the new tokenizer, which is 1.4x more tokens used. But if you test it on longer tasks, people have noticed that for a complicated task, 4.6 will use 200 tokens, but 4.7 gets it done with 70k tokens. So there's those trade-offs also. But eventually should all get absorbed with model improvements. But compared to let's say MCPs, right? So MCPs were all the rage for majority of last year, but I think if you use the cloud this Chrome dev tools MCP, it has about 15 tool calls, and same with the playwright MCP also. They do result in a lot of context pollution because each tool
I've seen like 15% context. Then I've used the Chrome dev tools thingy, and then it just jumps to 45 or 43, 44% context. It just fills it up.
Yeah. So that is, I think MCPs are a great use case for classic client server communication. If I have some data that you want, then you would use my MCP, and then you are that's a good layer of abstraction for you. But for doing local only stuff, you should rely more on skill.mds and direct CLI tools. Like for controlling a browser, you can use agent browser CLI and can get away with much less context usage.
Got it. So use an external tool which is specialized to do headless browser work, and leverage that instead of and I think it makes sense that MCPs are also very enterprisey in that sense, right?
Yeah.
And it is in a way it
Kind
has
of
also opened up a very interesting ecosystem for developers. Like, I don't remember Jira APIs being ever very friendly to use. But
yeah.
with MCPs, at least that problem gets solved, right? And the enterprise big companies are also realizing that our APIs may not be that good, but rather than fixing our APIs, why not just
Wrap an
hide them
MCP over
behind
it.
this
Yes.
MCP layer?
Yeah. That is a great the tides lifting everything up, so like these enterprise companies not having such engineer friendly APIs is now enabling a lot of more automation, right? So great. And yeah, make your own tool calls also is another thing, because if you really dig deep down the harness source code, you can have your own kind of tool calls which can be something new entirely. So that I've seen less of in the design patterns. But yeah, hooks is another thing. I almost missed that. So great use case for, I finish a feature, I need to update the docs, or I need to perform a lint command, like what we do in CI. You could, yeah, I mean, do that locally. Also have the agent perform that before you push it to Git. So, and some of these harnesses, like I think Kiro, they allow you to have a natural language prompt for the hook, and it just figures it out.
Yeah,
So,
because normally when I see hook, I look at it from a very, very small. My view of hooks is very small in the sense that I will use a hook to add the context used text at the end of my,
okay.
every run and so on. I would depend on my skill.md or my instructions or my agents.md to tell the, model that after you are done, do not commit till I approve it. But then that has always been, that rule has always been flaunted, right? It will say sorry once, and then it will be like, then it will say, okay, do you want to do git commit? I said, I will tell you when to do git commit, don't do
Yeah.
it. But if you use hooks and if you are forcing it, then actually it makes sense. One of the reasons why I sort of shied away a little bit from hooks was that, what if it makes my agent slower? But then if your hooks are at the right points in the cycle, right,
Yeah.
not after every point, then it is worth having these hooks.
Yes. And most of the, like, yeah, I mean, again, these terms are not that well defined. Like Kiro, I mentioned natural language, you can prompt a hook. But Claude Code, from what I remember, forces you to write, like, have deterministic code. Like
Yes.
Claude Code
You
itself
have to
will,
write a
yeah,
shell script or something. Yeah.
correct. So yeah, those are again new patterns that we notice. The next thing is the memory systems. So again, whole community is very divided on what's the best way out of this. But RAG was all the rage last year, and again, to put into context, the earlier models were, they had lesser of a context window. A non-fiction book on average is like 200k tokens. So now most of the models that come out are at least 256k. So RAG is slowly like less popular and good for some specific use cases, but that's the modern like change in trend of how the memory systems are working. And same with knowledge graphs also. No, there's no state of the art, I think, way that is commonly adopted for like having a knowledge graph and having your agent traverse through and build context for itself for a task. What we are seeing the most common way now, the idiomatic way to hand over memory, is simple markdown files. You can have it organized as like a flat structure or hierarchical structure. Karpathy mentioned the LLM wiki idea, which is basically a hierarchy, how you have an index and you organize your markdown files accordingly, and your agent keeps updating them and not let them get stale.
How is that different from a plan that with a checklist and all of that, or top level agents.md?
So the plan and the checklist comes in handy when you are like in the execution mode, you're trying to make changes. But for many agent use cases where you need to, you don't want the toil of rebuilding your context. That's where
Got it.
these hierarchical these memory
But then
systems.
do you keep on refreshing your agent's memory at the end, at the almost at the end of each task? At like you know that now I'm going to quit this agent. Do you tell it that okay, now remember everything that we said? Are you more pedantic towards conserving the memory of your agents and making them better, or is it more event driven? That okay, I did some good work in this project, there were some good learnings, let's say that there were some best practices that you newly discovered for doing XYZ, then you will tell the agent to do it, or you are like at the end of every session improve your memory?
With the coding agent specifically, I don't do any of these things, but the unlock here comes with personal agents, that you let it, like examples like OpenClaw and Hermes, that's in the next slide, but that's where it really has a huge unlock. And the thing you can benefit from here is you can have all your coding agent sessions be ingested and build a LLM wiki out of it. You're probably working on a fixed number of projects with fixed number of tools.
But that memory should be curated by a human also, right? Because there might be a lot of slop that gets produced during the memory creation itself.
100%. So there has to be a human in the loop for that as well. But the idea is probably the agent gets you till 90% and you prune out the excess parts. So the next thing that's very popular, which you mentioned a little while ago, get shit done. GSD is an example of is prompt templates as slash commands. So you have a very carefully prompted workflow that I want to work in this specific manner. The most basic example is the plan mode. Like I want to produce a perfect plan artifact. I should think of the big picture and the details, and then start the execution. So you can have a more complicated version of it, have a complex flowchart of like imagine like state machines. I'm going to do this, then that, if not this, then that kind of stuff. So those are like GStack and GSD, two popular projects which have done that. You start with some slash commands and the agent literally guides you that, oh, we've done this, now we got to do that. And you design the organization once, like how you want the workflow to be organized, but you don't have to prompt it again and again to work in a certain way.
So one pattern that I'm seeing here is that when you're exploring this entire landscape of this ecosystem around agents, you don't need complex problems to try out these tools. Like if you want to try out these tools, try them out irrespective of the problem you want to solve, maybe on a pet project or something. So that, like again, revisiting that thought that you never know when the idea will click that, okay, this fits in here.
Yes.
So exploration itself is a full-time sort of, exhaustive work when it comes to this entire tool chain of agents.
There's a running joke in Twitter circles that you basically have to be unemployed to keep up these days. Or you sacrifice sleep. So again, more patterns. Finally, the Pi agent, the best coding agent now, state of the art, is the extensions bit, right? You can literally prompt your workflow into existence and it will write deterministic code as TypeScript extensions. And you can have so much extensibility with such simple core. And that's a new pattern that we are noticing, is like Pi agent extensions, I think, is literally just-in-time software.
And one of the things that I noticed, like when I was explaining Pi to someone said that, oh, but you can use this in Claude also, that you can tell it that, add a skill or anything. But the very fact that Pi is built in its system prompt that you should extend yourself, here is the documentation, here are the examples. No one creates a Pi extension by hand. Because the agent is so well trained and it is like a first class citizen in asking. Like I don't remember Claude asking me, should I extend myself? But the very first time I asked Pi, for example, I needed my NeoVim, way of navigating the agent prompt. And that guy says, I don't have it, but do you want me to build an extension? I said yes, and it did it.
Yeah.
Right? So that part is very different.
That distinction is the, I think, one of the best, like the latest shifts that I've seen. You asking the agent to generate a prompt that it can follow later is very different than you asking the agent to write deterministic code that it can run later.
Right.
Because if let's say your workflow is very complex, then your Claude Code writes a huge skill.md. Then your model is still going through all that tokens, and maybe it will waver in its execution.
And it is unpredictable. For example, I told Pi to write a WimDiff extension so that every time it makes a change, show me a WimDiff window. And it worked in Pi. But when I did the same thing in Claude, when I did the same thing in OpenCode, it just messed it up. And it forgot at times. How I'm supposed to do it.
It's not a good idea to depend on the context rather than ask your agent to just write code like the Pi philosophy of extending itself. So that's an important pattern, and I think we'll see the same pattern across all the tool chains in the future. Make your own software, just-in-time software, however you want, however you please. So that's there. And the next thing which you're talking about a little earlier is personal agents. So thinking outside the engineering workflow, not just coding agents. The major unlock for OpenClaw was hundreds of providers. Like you could reach out to the agent through your WhatsApp, through Telegram, through iMessage, and a lot of they come with 100 skills inbuilt, and they can perform a lot of operations like any day-to-day things you wanna research about your travel plans, or you want to conduct deep research on some niche topic every day. What's the latest? You want to know what's the war situation. So the possibilities are endless there, and that was a huge unlock. A lot of connectors and a lot of skills prepackaged, cron schedules, because
a lot of security vulnerabilities prepackaged.
Yes, 100%. And everyone knows that it's very prone to do very risky things. My first experience with OpenClaw was I told it to go, here's my GitHub profile, please check all my projects. And it gave me my private repositories. I'm like, how did you do that? Like, oh, your GHCLI is authenticated. I just use that. The defaults are that it is made for non-techies primarily. So it just abstracts away, hides what it's doing. It's just not
shut up and take my access scenario.
Yeah. Take my tokens, take my access, everything. But there are some good patterns to learn from there as well, like the cron schedule, because the idea is that they're constantly running on a server, and that's why so many Mac Minis bought. So an always running agent can have much imagine whatever you want to do, and the possibilities are much more than a single coding agent running for one.
That I feel is a very good point. In fact, one of the big names in the Golang industry, Srijan Shukla, he works with the Singapore government. He actually took OpenClaw, he implemented it in Golang because he wanted to learn the internals, and then he wrote a blog post on how OpenClaw works internally. So it's a great way to see how someone has built a tool that just pushes the limits of agents, right? So full credit there. So we'll share these links in our in the video. That's worth going through and worth learning from. Like all of these tools, these tool chains, GSD and Paperclip and everything. The more I'm talking with Srijan, the more I'm realizing that you may not end up using them, but not exploring them, not understanding them, not trying to understand their design choice is something that makes us miss out on how they were built. Like if everyone would be interested in knowing how does Google operate at scale, but if someone brings that same mindset to exploring agents, there is a lot to be learned without creating a very harsh sense of judgment very early on.
Yeah, it just opens your mind to possibilities, and I always come back to the fact that like a lot of the notes I've taken over the years about just engineering is a lot of it is about this exists and this is possible. And just knowing that it opens you up to new ways of thinking. You might require it, you might not require it, but good to have that curiosity for sure. So with personal agents, OpenClaw is actually based on Pi at its core, and the idea of it running continuously in the background, even without permission. That's how we have an always running agent. The OpenClaw project also has things like soul.md, so you tell the agent to form its own personality and so on. And there's a Reddit community of agents, a lot of weird and fun stuff happening there, and very offbeat innovations. There's a feature called memory dreaming, where the agent dreams is what they call it, but it's going through your recent conversations and building up memory of things of what it has learned about you, how to better interact with you, and so on. So those are the patterns. Again, that is people are picking up those things and putting into their own projects. The next thing is Karpathy's AutoResearch project. Not a project, actually, just a simple Python script which is able to self-edit and perform experiments until it is able to maximize a function that you give it. So people are applying it to various levels of the whole AI agent thing. So you can. So
I have never tried this out. What could be a good example of using AutoResearch?
I would say start at the context layer. So a good example would be the next, what I mentioned, the next bullet point, right? You can go to your Claude Code, run /insights command, and what it does under the hood is goes through all your chats and tells you what to add or subtract from your Claude.md. So that is self. It's a loop on itself, self-improving loop. And you could apply it at various levels of the harness itself. You could the Pi agent extensions could improve over time based on the chat sessions transcripts.
But you also run the risk of sort of polluting or adding unnecessary context on all. Again, human in the loop helps.
Human in the loop has to be because the agent can go haywire, the models can go haywire with this. The Karpathy, I think, applied it to a local model. So again, you can apply it at the model level itself, improving into running local models and stuff. But not just, when I say the harness level, it's just not harness level also. It's just various levels of harness. There's multiple projects I think Auto Agent, and there's one more that I had. I'm forgetting the name, but they don't even when I say harness, not just harness, different levels inside the harness also people have applied this loop to get just better results. And the next thing is self-editing agents, which is very related to AutoResearch. So this was my experience with the Hermes agent, which is also a personal agent like OpenClaw. And I'm asking it to do things, and I noticed that after a very complicated session of the agent trying to figure out a particular task that I've given it and failing it at various points, without even me asking, it created a skill.md for itself and just told me in one line that, hey, I created a skill.md for this task for if you ever want to do it again. So again, that is some engineering at the harness and some engineering at the system prompt done for the agent. And the insights command that I mentioned is another example, which has human in the loop. Insights will give you a long HTML page, and you can pick and choose what you want to put in your Claude.md or agents.md. The other thing is, I'm not mentioned in the slides, but it's called, I don't know how again, you read this and you don't know how to pronounce it. It's a GEPA loop. So that is originally about feeding all your chat transcripts and figuring out the failure modes and not to repeat that, and letting your agents adapt, letting all the layers adapt to have a better experience.
Interesting.
And the last pattern is the swarm of agents.
We already spoke about that part.
Yeah. So Kimike 2.5, is a swarm of 50 agents trying to achieve some very complicated tasks. And there are these patterns of either you divide and conquer, or in Claude Code teams, the agents talk to each other. There is a leader agent that is keeping track of things of what the other agents are doing, and it's handling the coordination bits also. Mirofish is another example of like a huge swarm of agents doing various operations. Grok 4.2 was, yeah, just the main idea was that itself, that it has 16 predefined roles for agents, and they all act on your prompt and your context, and then they synthesize the output from that. So yeah, these two slides basically cover most of these patterns that I've noticed. And I'm left thinking that what am I engineering now? So the engineering has changed a bit in like day-to-day operations, and also in its scope, because now we are engineering workflows and flowcharts of how we want to get various kinds of tasks done. And you're thinking about like background jobs and maintenance. You can automate a lot of that with personal agents, with an always on agent. And I would say should try to automate as much toil as you can, the DevOps mindset, right? Not to have to uh, manually do an operation that you can do programmatically and prompt your agent that way. I would actually say, yeah, well, tell your agent to write deterministic code rather than a skill.md. To
Right.
If it is a task that can be done deterministically, yeah, we should do it that way.
Yeah, I actually have a skill like my agents.md has it. If I tell you to do a task and there is a script that can be written for it, ask me if I should write a script, and then I dump it in my bin file. Right.
Amazing. Yeah.
Something very simple like,
Right.
checking which GitLab jobs are running and which one failed. Right. It will keep on doing that GitLab API call again and again. But if I tell it that you already have that tool ready for you because you did it once and you wrote that code, then it also makes one's tool chain increase more, and you also end up like you will never read a skill.md as closely as you will read your code. Right? So might
Correct.
as well make it right code.
That is true. True. Yes. And you go your own, even with the frontier models, you don't get the confidence that it will run exactly the same way. A skill.md is followed exactly
Right?
the
And
same.
like a better concise language for skill.md is a programming language which will be a natural progression of thought itself. Then why not
Yeah.
make it write a programming language?
Yeah. Exactly. That's what works out best for engineering use cases. Yes. Well, let's say you're doing.
Yeah, I feel that a lot of people who are skill.md enthusiasts will slowly make skills.md very concise, precise, put in JSON, put in YAMLs, and then say, oh, this is more structured. But that is a structure that you gave up in the beginning to write a skill.md. Right? And now you're going back
That
to
is
it.
happening. A lot of skill.md. I have skill.mds, which I have not made, but the skill.md has code snippets that, hey, from your agent browser CLI, pass this JS to run inline and perform certain operations. So that's happening. But I think for non-engineering use cases, let's say I'm asking my agent to do a deep research on a particular, on a aviation topic, let's say. And then it becomes a little non-deterministic. I can tell the skill.md to use.
For those things, it makes sense. It will be
Yes.
non-deterministic.
Then let the model use its intelligence. It'll call some APIs, and then the later part that it does of presenting the information to me or putting it in LLM wiki, let that be your heuristic by the agent. So in those cases, skill.md is fine. But yeah, I think just digging more into what's happening under the hood helps us understand and see all these patterns and apply it to our context and harnesses for your fun projects, for your work projects, and everything else. So that's it. That's what we are engineering now, I think, and that's my talk.
All right, cool.
Thank you.
Lot of good insights, Srijan. Thank you for making time for this. And before we leave, I have two bad jokes for you.
Okay, I'm ready for it.
Okay, what is an AI engineer's favorite rock band?
Favorite rock band?
Yeah.
Okay, I don't know.
Rag Against the Machine. And their favorite song is Querying in the Name of.
Oh, nice.
I have another joke for you.
Full rock fan.
What is a VC's favorite rock band? And this is a band that you really like. This is one that you suggested to me. It is a wordplay on that band. VC's favorite band.
VC's favorite band.
Yes.
Mm-hmm. I don't know.
Seedhe Moat.
I'm one of the biggest fans of Seedhe Moth for those listening. So, yeah.
I still have to listen to the Seedhe Moth song that you sent me. But different conversation.
Yes.
But we'll wrap up this call. Thank you very much again for doing this.
Thank
A
you.
lot of learnings for us. And I feel that from my perspective, my mindset has changed now to explore what is out there rather than, judge it from an AI slop filter angle. See how
Right.
it is, understand what it is, and then take a call.
Yep. That's it. Thank you.
All right. Thank you.